It's another of those nicely machined aluminium components from China videos. And it comes about because in the past I've shown that I'll often test things like USB power banks for capacity by discharging them first. And I've tended to use, and I originally used to use these little flashlight adapters that have a on-off switch on them. And they're very simple, they're not super high current. But I laterally found these ones, which are much higher power, not the power they state, but a higher power nonetheless. And these ones have the sort of advantage of heat sinking around them, so they are probably better for the LED. It lets them run at higher power. Let me show you how much current these take, and we'll probably have to zoom down onto this. So I'll plug this Rudeng meter into here, and we'll zoom down on it. Let's see if I can actually make things in focus here. That's looking pretty good. So the plastic one draws, say 150 milliamps. It's kind of wavering roughly about 145, we'll say, milliamps. So not that high power. And the aluminum ones, they draw about 260 milliamps. So much closer to actually a 1 watt output. Let's zoom back out again. Thing to note about this, I found that the first time I used this, or the first few times I used it, when I plugged it in, I gripped it and was pushing a button in accidentally as I squeezed it into the socket, and I kept resetting the language to Chinese. I've put a video up now showing how to detect when you've done that, how it actually happens and how to set it back. I could show you again. When you hold this top button in and you plug it in, it initially goes through a menu. First it goes to Chinese, then English, and when you let the button go while it's on English, it switches back to English. It's worth knowing that. It was a bit confusing when it first happened. So let's take a look inside one of these, because these are the main subject of the video. Well, I'll start with the plastic one first as a refresher of what's inside them. So in the case of these ones, these are the first sort of plug-in USB flashlight adapters, and they've got a typical Luxian star LED. Do I have some of them up here? Yes, I do. These are a sort of style of LED. One of the first high-power LEDs just rated 1 watt, and they were supplied on these sort of star metal heat sinks, the sort of all aluminium, with the sort of layer of fiberglass on top, and then the sort of copper for the actual soldering of components, aluminium core PCBs. So they used one of those, and they simply used a little quarter-watt resistor which was being pushed quite hard, and this one's rated 10 ohms. Brown, black, black. 1, 0, and 0 is the decimal multiplier. And then a little switch jam down the bottom. Very, very simple, nice construction. I'm guessing this must just jam in, lock in this thing. However, the bit we're interested in is these, and things worthy of note, the fact it's turned leaves actually quite a sharp edge. Watch your fingers when you do this, but if you actually grip it tightly, and you have to grip it really tight because they seem to have used a thread lock on it, you can unscrew the back of this. And when you unscrew it, you've got this sort of visible thread lock around here. You've got the circuit board inside. Let's zoom down on this because it is pretty small. We've got the standard plastic collimating lens that seems to rely on refractive index to actually focus things and gather the light and fire it out the front. So it sits into that aluminium housing, and on this aluminium back bit we've got the circuit board, which in this case is not aluminium core. The circuit board is just a standard fiberglass one with double-sided, but they have peppered it with plated through holes just to try and transfer the heat to the back, and I'm guessing they transfer the heat from the LED onto this, and then this couples it through the threads onto the outer housing, and I've not actually tested for how hot it got in use. How could I do that? Well, you know how I could do that. Can I do it that way? I may play with that afterwards. I'm wondering if I could do it with the lens out. Hold on, let's do a little test here. Does it require that lens? I think it might actually rely on the lens pushing up hard against this circuit board. I'm just going to test this. Will it grip that circuit board on its own? We shall see. No, it doesn't. It relies on the lens in there pushing that down. Okay, that's a bit of a shame, because otherwise it would have been quite straightforward to check. I would want it pushed hard back against this to get that proper thermal test, and then I could have looked from the front with the thermal imaging camera. I may still do that. I don't know how well the lens would indicate this. I suppose ultimately, yeah, I'm really wanting to know the LED temperature, but having said that, it's not even going near 1 watt, so it's not that much of an issue. The resistor, and it's a nice big surface mount resistor. I was trying to get some of these, but it's quite an elusive size. This is a 6.2 ohm resistor, and it's really large. I'd guess it's probably rated the best part of half a watt, maybe higher, maybe a watt. And the LED just looks like a standard 1 watt LED, and I was thinking, you know, I do have other colours of LEDs up here, so like say for instance I've got blue and red, and I must have warm white somewhere. So I was thinking, let's actually change an LED in this and see how easy it is to do. So I'm just going to grab those bits and get the soldering iron on. I have found my favoured warm white LED. I also found this pack from a while back of red, green, blue fast colour flashing LEDs that claim to be 3 watt, but what they actually mean is it's in a 3 watt package. It's not actually rated for that. I suppose they could be pushed a little bit harder if they've got decent heat sinking. This same package, it originally started off being rated 1 watt, but then they found that as LEDs evolved, they managed to upgrade it to 3 watts. So a lot of things say 3 watt, but what you actually get is a 1 watt LED in it because it's that package, or a 3 watt being driven at 1 watt. So let's put this meter to diode test, not to test a diode or anything like that, but to check the polarity of this. So I'm just going to touch this on, and it's not lighting. Touch on here, and it is lighting. And I don't know if you'll actually see that. Let's try and shield it from the light here. Are you going to see that flash on? No, because I'm shielding it completely with my fingers. Just trust me with this then. It is lighting. So there is a slight notch out the contact in this one for that. So that's the positive. Rightio. So the first thing I'm going to do is I'm going to clamp the circuit board in the vise of knowledge, and I'll zoom down in this. So let's get this in. How's it going to hold it quite well? Yeah, it's going to hold it nice and tight. And I shall wet that solder. Let's zoom down a bit. Oh, let's zoom back there, and how's this looking? It's looking pretty good. Is that focused? I think that's focused. So I'm going to wet the solder on these first just to add a bit more flux, because it just helps with the desoldering. So I'm applying a little bit more lead-based solder onto it. Juicy lead-based solder. Let's grab a pair of long-nose pliers. And I'm going to grip the LED, and this might look a bit destructive doing it this way, but I'm going to lift it up gently while I heat one of the pads, and I'm going to hinge it up slightly. It's not hinging up terribly well, but that's okay. Now I'm going to do the same on the other side, and because I'm doing it this way, I shall hold the solder iron the completely wrong hand that I'm not used to here, and we'll try and hinge that side up so it's going up nicely. And that should be clear at that side, so theoretically I could just melt this and off it comes. Okay, now there's a couple of approaches I could do here. I could try and remove the solder off the existing pads, or I could just try and get the new LED roughly located. And I notice there's an outline. Can you see the sort of line they've got around there that's going to help align this up? I think I will tin the underside of the LED pads. I'll maybe also put a wee dot of heatsink compound in there. So let's get the heatsink compound in. This is where I squirt it, and all the oil, that the carrier oil comes out. That sometimes happens. What have I got here that I can smear this on with? This random little screwdriver that came with something. I can use that. So I'll put a dot of that in. That's probably far too much. It's going to squish everywhere. And yes, it is. Well done. That's me keeping my standards up to the usual level here. And I'll just put this now manky little screwdriver somewhere I can pick it up with the wrong end and get silicon all over my fingers, the silicon stuff. I'm guessing that this stuff is the basically silicon oil with zinc oxide in it. That's just a guess. I think that's what the earliest thermal pastes were. So to solder this, I'm going to grip the LED and I'm going to just tin the two pads. I could do them one at a time, but I'm going to be greedy and try and get both from the same position without changing hand position. Oh, is that going to work? That did work. So now I've got solder underneath the pads for the LED. I'm going to roughly line it up. This one says positive, this pad, so I'm going to splat that down there into that compound. This is where it all squirts out and covers the bit I was supposed to be looking at to line it up. Because this has to be fairly central. Yeah, that's totally going to happen, not to worry. So let's flow it down initially. That's almost looking quite goodish, I think. That's looking very good. So I'm now going to flow the other side, destroying everything in the vicinity. Is this a wee bit ferocious at the moment? No, I'm not going to be able to adjust the exposure at the moment. So, right, so let's flow this pad here. And press it down. Okay, looking pretty good. And now I've done that, I'm just going to make sure the other side's level as well. So it is right down, so that's fine. That's looking pretty good. And I reckon that theoretically, I could just take that out and I could plug it into a power bank and see what happens. It's lit, nice warm golden white, which is going to look sulphury and yellowy in this particular video. So what sort of current is that drawing? Let's plug it in here into the Teardown. This particular LED is coming about 230 milliamps. That's okay. And the voltage across it will be roughly about 3 volts. The dissipation will be about, say, 3/4 of a watt. Now I'm going to see if it actually fits in here, because the centering of that is quite important for going into the lens. I don't know how they manufacture them in the factory I don't know if they use some sort of jig to hold it in place, or if it's automated assembly. Who knows? So let's screw this together. It does look quite well lined up. And there's my warm white. Yeah, that's quite nice. A good beam of light coming out of that. There's my warm white flashlight now. That's interesting. Flushed with success. Should I be reckless? Should I try and put one of these in? These colour changing ones? I think I should. And see if we can make the disco flashlight. So once again, I'm going to grab the other light, which I've already loosened off. So let's stick this into the vise of dismemberment. I'm going to bring the meter in and test this, because there's a little indent, and if that indent, it does mean the positive. But you just, Chinese LEDs, the LEDs from the usual suppliers, I say all LEDs are more or less Chinese, aren't they, these days? But the usual suppliers from eBay, you just don't know what you're getting polarity wise. It just really is whatever way it happened to go through the machine at times. So that's showing a diode, which is why these fail horribly when you connect them up in reverse. That usually kills them instantly. And that is going through its little colour sequence quite dimly. So the little indent this time is actually negative. It's not the same as the other LED. So let's do exactly the same, and I'll zoom down for this again. If you get bored, you can just skip forward to the end and you'll see the sort of effect of it, because I'll show it operate in the dark. So I'm just going to flow some solder onto these. Grab the long nose pliers again, which I've misplaced now. That's a pair of snips, that's not going to do anything. Here we go, I'm going to grip the LED and apply slight angular pressure on it to lift it off. Tilt it up. And that's tilted so clear that I may be able to just grab that if I heat the other pad. I'm able to just lift that off. No, I'm not going to. I've spoke prematurely there. It was held by... When you lift it up, it sometimes drags a little bead of solder up with it, a little peak. Yeah, that's off now. Right. Do I add a bit more? I'll tell you what, that screwdriver had a bit more of the silicone on it, so I'll just put a tiny wee bit on. And people are saying, yeah, that's the right amount, you used far too much last time. Yeah, I know. Right. Put that bag of LEDs up out the way. And I shall tin the bottom of these again, this LED. See if I can grab hold of the red hot pads or just even solder my finger instead. Now that that's got fresh hot solder on it, I will burn myself on it. Touching that one, there we go. That's perfect. The other hand, if you don't find these boring, if you quite enjoy it, remember to subscribe. It's worth mentioning that, and if you've not been getting notifications, then YouTube may be up to its shenanigans of disabling all the sort of notifications. I think they went through a spell a while ago where they just cancelled a lot of notifications simply because they couldn't keep up. Is this looking fairly... Oh no, I've just completely messed it up. That's okay. I notice, oh no, that's the socket that's coming in the back. I wondered what that was there. No, just ignore me, I'm rambling. As I often do. So I'm going to go purely by the wings this time for lining it up. So that wing goes into the middle of that pad. How's that looking? It's looking squint, but that's okay. I have no qualms about that. I can line it up afterwards. So let's swing that round. It's riding up on the original solder pad. So now that's cool. I can just perhaps press this down and reflow these solder joints and on either side until it just sits absolutely flat. That is looking perfect. It might not be perfect. I might have soldered it in the wrong way around. Causes a little avalanche in the background here. Let's zoom out, get rid of the vise, get rid of the long nose pliers and plug this into a power supply and see if it nukes the LED. It's going through the colours. Interesting. What sort of current is it drawing? It's drawing, peaking about 80 milliamps, which is quite a lot for a red, green, blue LED, but keep in mind this does have a proper sort of heat sink on it, so to speak. It's got a proper package. So now let's feed it back through here and see what effect it has when I point it at a surface that is more appropriate for viewing the output. I would guess that because the chips are not centered, in fact they're really not centered in that it will probably be shooting a beam out at a funny angle. One way to find out. Righty-ho, so let's turn this light off. Let's take the exposure off, in which case this is just going to go completely... Actually, that's not bad, is it? That's showing a rough... It's brighter than it looks. Hold on, I'm going to take the exposure off and then it'll be completely screwed. Oh, it was completely screwed. But there we go. Oh, I should actually say, flashing warning. It's a bit late for that. I'll try and remember to put that into the description, that there is a strobe warning in this, because it does go bright. Now, the red is actually just filling in this small area here. Can you see that? And the green and the blue's actually more or less filling just over the red. Red, yes. Let's start again. The green is projecting the largest circle here. The blue's a bit smaller than that, and the red is right in the middle. But it's interesting that it does appear to be collimating it, even though they're off-center in the LED inside that. It does appear to be spreading the light about. And it's incredibly annoying, so there you go. Instant disco accessory for your power bank if you get one of these. So I shall provide a link. Watch yourself, I'm turning the light on so it's going to be bright. I shall provide a link to a search for these little lights. These are described as 2W, 2 watt, USB flashlight, major difference in price. I will provide a my usual link. I'll provide it to eBay. And now, what's the focus like on this at the moment? Am I kind of... There we go. I shall provide the usual link to eBay, but with the lowest price first for the search, because the price varies from 99 cents or less for these, shipped, to a ridiculous price I found at a UK seller selling them for almost £15 each. They were just taking the piss really there. I don't know if that was one of these, we'll get it, we're out of stock, so we'll just put the price up. But they seem to be listing some in stock anyway. It's a bit shady. But that's that. So they're good little things. They're quite nice. The target price then to look for these is between $1 to $3 probably. And once you've got that magic keyword, which is the 2 watt bit, 2W, then they're quite easy to find. Before that, when I was looking for even these, I couldn't find them because you hit that magic keyword and then everything pops up. So that's it. A nice little hack, a nice little modification, and even on their own, in the original form, a very useful little extra thing to have, because it does convert an ordinary power bank instantly into a flashlight that you can actually adjust by changing things like resistors or LEDs. You can get any colour or intensity or whatever you want from these things, and they're also quite nicely machined too. Bonus.